Hi guys, so today we're given the problem. The truss is supported by a pin at A and a roller at B. Determine the support reactions. So first how I'm going to start off this problem is by actually drawing out what the support reactions are and where they act. So as the problem stated, there's a pin joint at point A. This means there's an X and Y reaction on it. So I'm going to draw the A of Y as the Y reaction, and then A of X. And those are the two reaction forces at point A. And then at point B, it's a roller joint. Roller joints only have reaction forces in the Y direction. So there's a B of Y acting upward right there. So now that we've drawn out all of our reaction forces, we can start to create our equations of equilibrium. So let's start by creating these equations of equilibrium. Perfect. So for the first equation of equilibrium, I'd like to start out with the sum of the forces in the x direction equals 0. So to start this one off, we have our A of x, support reaction of course, and then there's one other force, which if you picture this part of the truss right here with that 5 kilonewton reaction, now you can see that there's that 45 degrees of that is part of that truss where it's angled at. So if you want to go ahead, you can picture it as a right triangle. So then now we can know the x direction and the y direction. So the 45 degrees is adjacent to the x-axis. Therefore, we're going to be adding on a 5 cosine of 45 as the other x reaction in this truss. Next, so now that we have this equation written out, we can go ahead and just solve for A of x. So I'm going to go ahead and plug in the number into my calculator, and it should come out as a 3.536 kilonewtons. So that is what you should be getting for your A of x support reaction. Next, let's move on to our next equation of equilibrium. And I'd like to take a moment. So I'm going to create a moment around point A and take my moment around point A to do my equation of equilibrium around there. So you can do it around point B if you'd like to. However, you'd have to include the A of x and the A of y force in your equation. Whereas if you just do the moment around point A, then it makes it a tiny bit simpler because then you won't have to include an extra force into that equation. So when I'm creating this sum of the moments around point A, I'm going to start by including my B of y force. So I'm going to work my way to the left in terms of forces. And its distance is going to be the original 6 meters that it is from. And then I'm going to add another 6 meters. However, these 6 meters right here aren't actually a full 6 meters because it's at an angle, and that's the hypotenuse of the right triangle that we just made. Therefore, it's actually 6 plus 6 cosine of 45. So next, let's move on to the 10 kilonewton force that we see. So it's going negative in the y direction, so it's minus 10. There's an original 2 meters, and then as we did in the last time, we're going to be adding another 6 cosine of 45. And then additionally for the final force, it's that minus 5 kilonewtons going negative in the y direction. And then that is 4 meters away from our A point. And then set that all equal to 0. Once you're done plugging in all those numbers into your calculator, you should be ending up with around 8.047 kilonewtons. So that is your final solution for the B of y force. Finally, let's just do the sum of the forces in the y direction. So let's do the sum of the forces in the y direction. Those are equal to 0. So you have a of y is one of the forces that we're trying to solve for, plus the original 8.047 that we just solved for, that's the b of y, minus a 5. This time, if we look at the right triangle for that 5 kilonewton force, the 45-degree angle is adjacent in the y direction to the y-axis, so it's going to be a minus 5 sine of 45, and then minus that 10 kilonewton force that we see on the top. Set that all equal to 0. Once you're done solving for that, you get that a of y force is equal to a 5.489. And that is your final solution for the a of y, the b of y, and the a of x reaction forces. Thank you all and have a wonderful day.